Book summary. Low-Quality Reservoirs, Real Opportunities, Strategic Responses to LQR Challenges in Mature Fields. By Andy Enriancia. 1. The Central Problem. Low-Quality Reservoirs, Real Opportunities argues that the biggest problem in mature low-quality reservoir, LQR redevelopment is not a lack of technology. The deeper problem is poor decision discipline. The conventional industry narrative is, the reservoir is underperforming, apply better technology, increase production, recover more value. The book challenges this sequence. It argues that the correct sequence is, understand the physical constraint, determine what is actually removable, quantify uncertainty, test the economics, commit capital, gradually stop when evidence says stop. The author emphasizes that many projects fail long before the well fails. By the time production comes in at 1/3 of forecast, the fundamental decision error has already occurred during technical evaluation, business case construction, and capital approval. The book therefore reframes LQR management from a technology selection problem into a decision under constraint problem. 2. The book's core thesis. The central philosophy can be summarized in one sentence. The discipline is the strategy. Stimulation, artificial lift, EOR, workovers, facility upgrades, and redevelopment programs are tactics. The strategy is the discipline governing. How those tactics are evaluated. How their uncertainties are tested. How capital is staged. How performance is monitored. When continuation is justified. And when the organization must stop. The book argues that technically competent interventions can still destroy value when they are embedded in a weak decision system. Conversely, even failed pilots can create value if they preserve capital and generate information that improves subsequent decisions. 3. What low quality actually means. One of the book's most important contributions is its rejection of the idea that LQR is simply synonymous with low permeability. Reservoir quality is treated as a multidimensional system involving 4 structural axes. 1. Storage capacity. 2. Deliverability. 3. Connectivity. 4. Heterogeneity. The book particularly emphasizes that connectivity and heterogeneity can be more strategically important than absolute permeability. 2 reservoirs may have similar permeability but radically different economics if one is well connected and relatively homogeneous while the other is compartmentalized and highly heterogeneous. This distinction matters because different physical problems require different responses. A permeability problem may potentially respond to stimulation. A connectivity problem caused by sealing faults or stratigraphic barriers may not. The first strategic question therefore becomes, what exactly limits this reservoir? Not, what technology should we apply? 4. The physics comes before the business case. A recurring principle throughout the book is, reservoir engineer capital. The reservoir imposes physical limits. Engineers interpret those limits. Capital should only be committed after those limits are understood. The book identifies KH as a particularly important flow capacity parameter and repeatedly warns against using assumed or analog-derived values when direct evidence such as pressure transient analysis, PDA, is available. One of the strongest conclusions is that KH not being properly confirmed before capital commitment is the most common single point of failure across the cases analyzed. The book states that this problem propagates into stimulation, artificial lift, forecasting, and kill criteria decisions. This creates a powerful decision rule. Do not build sophisticated economics on top of uncertain fundamental physics. 5. Why common LQR interventions fail. The middle portion of the book examines the major intervention categories. Stimulation. The book challenges the assumption that a successful fracture or acid treatment automatically means successful economic rejuvenation. A designed fracture may have a much smaller effective drainage contribution than the model assumes. Post-treatment production can also exhibit a temporary spike followed by accelerated decline. Therefore, stimulation must be evaluated using historical calibration and realistic decline assumptions, rather than design model optimism. The book recommends testing whether economics remain viable if post-stimulation decline is materially worse and the benefit period materially shorter than the base case. Artificial lift. Artificial lift cannot manufacture reservoir inflow. A lift system designed around a target production rate rather than actual reservoir deliverability can create cycling, instability, excessive operating costs, and equipment mismatch. The correct question is, what lift system fits the reservoir's actual inflow? Not what lift system gets us to the target rate? Water cut. In mature LQR systems, water is not simply a production variable. It becomes an economic variable. As water cut rises, oil production declines, fluid handling increases, operating cost per barrel rises, facility capacity becomes constrained, and eventually the well can become a cost center. Therefore, each field and well needs an economically determined water cut limit rather than a generic operational threshold. The book is especially skeptical of premature EOR proposals. OR is not presented as the inevitable next step after primary and secondary recovery. Instead, the reservoir must first earn the right to receive EOR capital through technical readiness. For example, the book provides screening benchmarks such as minimum permeability for polymer flooding and emphasizes the risks of channeling and poor conformance in highly heterogeneous systems. These values are explicitly presented as screening starting points rather than universal substitutes for field measurements. 6. Surface facilities are part of the reservoir economics. A major strategic insight is that subsurface value cannot be evaluated independently of facilities. A reservoir may technically contain recoverable hydrocarbons but still fail economically because a water handling capacity is insufficient, a compression requirements arrive too early, a minimum facility throughput is too high, a late life operating costs escalate, or retrofit requirements consume the remaining value. Therefore, reservoir development, facilities, and economics must be evaluated as one coupled system. The question is not simply, how much oil can the reservoir produce? It is, how much economically deliverable oil can the integrated reservoir, well, facility system produce? 7. The shift from full-scale commitment to phased investment. One of the book's strongest recommendations is the pilot-first philosophy. Instead of large capital commitment hope production result, the book proposes small capital commitment information decision gate larger commitment only if justified. A pilot is therefore not merely a technical experiment. It is a capital preservation mechanism and information generation mechanism. The pilot should establish a what must be proven, a what constitutes success, a what constitutes failure, a what data must be collected, a when the next investment decision occurs, and what conditions trigger termination. This creates a learning loop rather than a one-way capital commitment. The book explicitly positions its phased redevelopment templates as operational decision tools rather than merely reference material. 8. Forecasts must be tested for fragility. The book argues that a forecast can be technically sophisticated and still be strategically dangerous. The critical question is not, what is the most likely forecast? But, which assumption breaks the economics first?